Well, we're here at the stand of the Oil and Gas Technology Centre, the OGTC, and they always have the exciting stuff. I'm joined by Matthias and Chris. Chris, you're from Total. Matthias, tell us about, I know that you've got a really exciting, eye-catching robot that is being on show here at the exhibition. Can you tell me a little about how that came to fruition?
Yes, so initially we started building robots for firefighters, fire departments, so they put themselves at risk when they enter buildings because there may be radiation or gases or other dangerous substances around. So we thought when we started our company to build robots that can enter those buildings without putting their lives at risk. And all our robots were ATEX certified. So that was a very important stepping stone for us to enter the oil and gas industry. ATEX means robots can enter explosive atmospheres, which are also obviously around in the oil and gas industry. So that was our transition towards the oil and gas industry. And the entry was actually the Argos challenge that Total brought about, which Chris will talk a little more about, I'd say.
Sure. So in 2013, Total launched a terrestrial robotics challenge called Argos, Autonomous Robots for Gas and Oil Sites, an international competition with 5 teams, and Taurob were the very worthy winners after 3 competitions. And that's the robot that we have here today. And we'll also be showcasing for the first time the new prototype, which is the partnership with the OGTC and the next step of the project.
Yes, how did the partnership with OGTC come about?
Well, in November 2017, we submitted an application, a joint application with Total and Taurob to OGTC. We know that they take technology very, very seriously in trying to maximise economic recovery in the North Sea. We want to test this new robot first at the Shetland gas plant, and then we'll take it offshore to Culzean. And then also test on our normally unmanned installations such as Franklin and West Franklin. So the OGTC, Total, Taurob, it was the perfect fit.
Oh, that's splendid. So tell me, where do you think, if we were coming back and speaking to you in 10 years' time, in 20 years' time, where technology like this is going to be playing a part in the oil and gas and energy industry?
Yeah, we hope that robots will really be a facilitator in the oil and gas industry, taking people out of tedious tasks, for example, or tiring tasks, and also take them out of risky situations, obviously. So you could really employ robots in order to go where people may not have to go in order to avoid them exposing themselves. And also, obviously, cost-saving potential by having robots on site, doing more repetitive tasks and having not to have people on installations all the time and not fly them in all the time. So there's a lot of cost-saving potential and making plants more efficient in the future.
Maybe it's a reflection of my age, but you grow up and you think that robots will be taking the place of humans in the future, but this technology is actually here, as we can see. We're here. This is happening.
Yeah, I mean, we had the vision in 2013, to deploy these kind of robots for an emergency response. If we have a problem, say on a wellhead platform, we could deploy it from the main platform across the bridge, could perhaps localise leaks a lot sooner. Now, with these robots, we have to deploy them first in a human-engineered environment, collaborating alongside operators. And then we can learn the difficulties of how the robots can actually manoeuvre around plants that are designed not for robots but for humans, and then with all those difficulties we can learn on that, and that helps us plan and design future platforms that are then more robotised or robot friendly, and that will then help us for the future, and starting to remove personnel from offshore and have them doing different roles onshore. But that's a much longer term vision.
I'm going to ask you just to very quickly come over with me to show you this prototype. If you can just kind of talk us through what we see before us here, and I'll get out of the way of the camera. I don't know if Matthias, perhaps you should...
Sure, yeah. So what you see here is our Argos Challenge winning robot, which is basically here as a museum piece, we call it, because there has been obviously a lot of development going on since 2017. But it's nice to explain the basic features of those machines, how they would work in the future on oil and gas sites. So basically you have a tracked vehicle where you have two tracks that can move up their flippers in order to really climb up stairs, overcome obstacles. You have a sensor head in here, which is very important in order to detect the anomalies you would like to detect. So, for example, sea gas leaks, for example, by thermal detection. You detect dial gauges, water fill levels, and also have actually a nose on the robot, a gas sensor that can also detect gases by sniffing them actually.
It's quite incredible. I've just asked a quick question before we have to go. When I see technology like this, I do think, gosh, the money that must be involved in here. This must be very expensive kit that we see.
It's certainly expensive. This is very valuable to us in terms of the financial, but also the sentimental. But again, with the OGTC, they are providing fantastic support there. What I find important is the fact that, and one of the reasons that Taurob won the competition was the fact that we need these robots to be ATEX certified. You know, to have these deployed offshore, they need to be designed to work in a potentially explosive atmosphere. So yes, they cost a lot, but they are designed as such to be future-proof and to last for many years.
And maybe in addition to the cost factor, it's not the cost of the robot, but it's also the cost-saving potential that is involved with those machines and entering them on oil and gas sites.
It is the future. It is fascinating. Thank you so much for explaining that to us, and all the best for the rest of offshore Europe.
Thank you very much.